In this lecture, we'll keep working on the arithmetic sequences. The first example is to find the sum of all integers from 48 to 95. It sounds like an easy job, even without learning again the arithmetic sequences. But you know, here is 48 to 95 is not hard. How about I say from 48 to 295? You know, that's not an easy job for you to do. Okay? You may spend a day and may not get the good answer, correct answer, if we do not use the knowledge right here. Alright? First of all, we want to know is from 48 to 95, the sequences will look like this. 48 to 95. Yeah, then, you know, everyone knows that. And then we know this should be the arithmetic sequences. Okay. So is arithmetic, not arithmetics. Okay. So which is arithmetic sequence? If it's arithmetic sequence, then you should have a difference, common difference. Well, common difference you can always find out is from the second one minus the first one. Okay, so down here we don't really need to find out that. We can use our common knowledge. You see, the number of tens is this much. You may wonder why. Now let me shade it. Look. How many tens from 48 to 95? You may think, 95 minus 48. The answer is wrong, Okay? Why? Look. How many tens from 48 to 49? You may say that's easy. That's 2. Why is 2? You see, this is easy to find. But if you use 49 to minus 48, you only get 1. From 48 to 50, there are 3 tens. You use 50 to minus 48, you get 2. So it's always 1 less than the number of tens. Okay? So down here, we use our common knowledge is 95 minus 48, and you have to add 1. Okay? Yeah, for example, if here is 51, would be what? 4 tens. 51 minus 48, you only get 3. So 4 tens, when you do the subtraction, you get 3. And then here is 95, you subtract 48, you have to plus 1, Okay, 95 plus 48 is 47, okay. 95 minus 48, 47 plus 1 is 48, okay. Yeah, so you know the number of tens is 48. And then you can do this one very easily. Why? The first 10 plus the last 10 times the number of tens divided by 2. That's the formula. Okay? Again, you want to repeat first 10 plus the last 10 times the number of tens divided by 2. Okay? Again, here is 48. With 2, you have what? 24 right here. Okay. And 48 plus 95 is 143. You times 24. You have the answer. 3,432. That's the answer for that. So, all right. Okay, there's the first example. Now, let's look at the second example right here. The second example is here. We want to find a formula for the nth term, so you want the general formula. of the finite arithmetic sequences shown in the graph. You see, this is like decreasing sequence. And then, it's not there, then specify the domain and range of the first 5 terms. All right, here we want the formula for nth term. That's the thing we want to do. Okay, and then you got to remember the formula you have to use. What's the formula for the nth term? Okay, nth term is always the first term plus what? Yeah, that first term plus the n minus 1 times d. But you know, right now, right here, we want to figure out the first term first. First term you want to do is like here, the first term is 19. Okay. And then you want to see the between the first term and the second term, that will be the common difference. As always, the second term minus the first term. Don't do this term minus that. Don't do 19 here corresponding to 19 is dot, and here is 16. So it's not 19 minus 16. It's the following term subtract the first term. Okay, second term minus the first term. Third term minus the second term. That's the difference. And down here is 16, you see, minus 19. So that's what? Negative 3. So you know the first term, you know the common difference. Then you, by formula, you can have the nth term. Okay? So again, up to now, this term should be, this formula should be in your mind very firmly. Okay? So that will be what? The first term is 19 plus n minus 1, again, is 1 less than n, and then times the common differences. So you want to simplify this term, okay, simplify this expression. So you will then have a 19 plus, do the distributive property, Yeah. So you have negative 3 times n, negative 3n, negative 3 times negative 1 plus 3. 3 plus 19, 22, minus 3n. Okay, from here. All right. Now, that's basically what? The general formula. So from here, you can find any term you wanted. For example, if here is 5, n is 5, that will be the fifth term. So you plug in right here is 3 times 5, 15. 3 times 5 is 15. 22 minus 15, you have what? 7, which is 7 right here exactly. You see? This point horizontally corresponding to a point between 6 and 8. Okay? That's 7. All right? So, what is the domain for the first 5 terms? Domain is easy. 1, 2, 3, 4, 5. And then, what is the range? The range you can count from here, 7, 10, 13, 16, 19. Okay? So, 7, 10, 13, 16, 19. You see right here. 7, 10, 13, 16, 19. All right? What I wrote in this way is because 1 corresponding to 2. You see, A1 is 19. And the second 10 is 16. The third 10 is what? 13. And then the fourth 10 is 10. The fifth 10 is 7. That's why I write in this way. Okay? Okay. I'll see you next time.